Good evening, friends. Welcome to ESN Academy. And we are discussing about digital electronics as a part of embedded system programming course. And this is the session 6. In this session, we are going to discuss about tri-state logic and its applications. We have discussed combinational logic and sequential logic, now tri-state. That's enough. If you know the three, you can build any digital applications and digital circuits. Only three. And the most easiest one is this. Okay, you'll be very surprised. What is this? Okay. Let's get it. It's a very simple electrical principle. We all know that the electrical principle very well. We all know that the electrical principle very well. So I have a battery and I have a ground. Negative is connected to ground. And in the battery, I connect it to your bulb. Sorry, not a bulb. A switch. I connect a switch. Understand? Now, let us assume the switch is on. S1 or A. Let us call A. Switch A. A is on. When switch A is on, the output becomes 5 volt because this is 5 volt. When switch A is on, you get 5 volt. When switch A is off, what is the voltage? When switch A is off, what is the voltage? Can anybody tell me? When I put the switch A off, what is the voltage here? Now, anybody else? I got one answer. Anybody else? Here, normally we think 0 volt. Normally, when I say switch is off, people think 0 volt. But if it is 0 volt, let us assume that I have another bulb, another battery. I connect a bulb here. I get here 5 volt because this is 5 volt. Understand? If this is 0 volt, when switch is off, if I connect this bulb and this, the bulb should glow. Am I right? But the bulb will not glow because the circuit is not closed. But one place is 5 volt, one is 0 volt. Why bulb is not glowing? Something is wrong. What is wrong? Because when the switch is off, this is not 0 volt. This is called no voltage. Now I'll explain to you now. I will explain to you the difference here. The difference has to be understood by you very clearly. Otherwise, always confusion. I have an output. I have a switch. There's a battery. The battery's ground is connected here. And battery's top one is connected here. Understand? When I put the switch A, then what happened? The 5 volt goes here. This becomes 5 volt. That is fine. When this switch is on, the 0 volt goes here. This is 0 volt. When both the switches are off, this becomes no voltage. Understand now? Now I will draw it one more way. I'll talk one more. Everything is only switch. Don't get confused. I have a switch. I have an input. This is input. This is the output. So I draw a table. I draw a table. I have input, I have output. And this is called control, or we can call enable. When the enable is 5 volt, when enable is 5 volt, the switch is going to be on. When enable is 5 volt, switch is going to be on. Now, how I give an input? I have two possibilities for the input. Am I right? Battery. This is connected here. And this is connected here. When the switch is stop, I give 5 volt. That time output become 5 volt. So input is 5 volt, output is 5 volt. When I put the switch bottom, the input is 0 volt. Then the output is 0 volt. Now, when I give controller 0 volt, what is happening? This is off. When this is off, this become input could be anything, 0 volt or 5 volt. Because the input and output are no connection, the output is no voltage. Or we can call open. You call anything. That's why it's called, this switch is called the input is two states, but the output is 3 state. What is the use here? You may ask that. You may ask me a question, what is the use of the tri-state? Now I'll give you the idea here. Now I'll give you the idea. Then you'll be very surprised. Take a railway station. Take a railway station. You take a railway station. There'll be a platform. And there's a track. There's a track. Am I right? There's a track here. Now, normally, there are so many tracks. One may be coming from place X. One may be coming from place Y. One may be coming from place Z. Various places. Let us say, one could be coming from Chennai. One could be coming from Calcutta. One could be coming from Bombay. One could be coming from Kashmir. So many things are coming to Delhi. This is a Delhi station. Now, what happened? Here, there'll be only one platform. Now here, all these things will be controlled by the lineman. They can connect anything here. That train will come there. So for the time being, this will be connected to this track. Only this train can come here, not the other train. There's only one platform, one track. Now there'll be only one train can come here. Same way, this train can go to anywhere. Okay, they will be able to connect this one to this one, this track. That time this train will go to Chennai. And this train will go to Kashmir. So if I want to coming from Chennai, want to go to Kashmir, they will control this. And if I are coming from Calcutta, want to go to Chennai, this will. So any train can go to any train. But suppose if nothing is connected, now that time this train is this platform is called not connected to anybody. No train. Understand? Suppose I have connected to Chennai. Now the platform is connected to Chennai train. Allotted to Chennai train. But that doesn't mean that others can come now. This is allotted to Chennai train. Now, when there is a train, Chennai train comes here. If it is coming late, still the platform will be allotted to only Chennai. You understand? Now the same thing here. No, I will give you here what happens. Here also this very well used. I have a single wire. Now I have a multiple inputs. I have a multiple inputs. Understand now? I have a multiple outputs. Now, if let's say this is A, B, C, D, E, M, N, X, Y, Z. There's only one wire. See that there's only one wire, single wire. Now, if this is called enable A, this is called enable B, this is called enable C, this is called enable D, this is called enable E, this is called enable M, enable N, enable X, enable Y, enable Z. You have so many enable signals. You understand? Now, if I give, for example, enable D as 1 and enable Z as 1, that means that this is going to be on and this is going to be on. So this input through the wire, it goes to the output. So any input can be connected to any output based on the switches. This single wire, for example, when all of them are zero, then this wire is called no voltage. Do you understand now? This is one of the very, very important functionality used in your digital electronics, because it saves a lot of wires for me. Why? I will explain to you that in the microprocessor class. That I will know that, because we have thousands of components in the board, motherboard or everywhere, embedded board. But at a time, you select only one component. All the other components are off. That even at least, tomorrow, next session, that is Monday session, when I'm explaining about the ROM, you will understand. Or RAM, sorry. You will understand the use of this. So please understand, I have so many inputs, I have so many outputs. Okay. But sometime, this is like this. I draw it like this. This is as simple. See, there's nothing to explain here. Now, I have two inputs. D0 to D1. I have another one. Let's say A0 to A1, sorry. A0, A1. Other one is B0, B1. C0, C1. Only three we take. We have X0, X1. Y0, Y1. Z0, Z1. Now there are two wires. And here there are two switches. Please understand, there are two switches. I'm expanding a little bit more. But these two switches are controlled by same signal called enable A. These two signals are controlled by same signal called enable B. These two signals are controlled by enable C. Now what is happening? We have connected them like this. See here, this is connected to this. This is connected to this. And this is this output. It's connected to this. Let me draw different colors, then you will know that. We connected this to this, this to this. Then we connected this to this and this to this. That means that you will do only pair. Let's say if you call this as a M0, M1. Now, If we put enable A, the A0 and A1 goes to M0 and M1, both. That means that you cannot on only one switch. All the pair will be on. So normally we don't draw like this. This is a boring. That's why normally we draw like this. We draw like this. 2. Same. When I put 2 means 2 wires. 2. A, B, C, X, Y, and Z. This is M. 2 wires. Now we connect them, all of them, like this. I can also connect 8 wires. Doesn't matter. Now I'm going to give you some important tip. That has to be the whole digital logic works on that. Let us assume that I have an AND gate. I have an OR gate. I have 2 inputs. And I connect this. And I connect this. Understand now? This is called A and B. And I connected them short, and this is a Y. Now what happens? Let me know. If we give here 0, 0, this is 0, this is 0, this is 0. Fine, no problem. Both are 0. If we give both of them 1, 1, and this is 1, and this is 1, 1, 1, the output is 1, no problem. If we give 1, 0, what happens? If we give 1, 0, what happens? This is 1, 0, 0. That is 0 volt. And this is 1, 0, 1, 5 volt. Now one is 0 volt, other one is 5 volt. What will happen in your plug points in your house? If you connect phase and neutral, we call them short circuit. Like that. If one is 5 volt, one is 0 volt, these 2 guys will short. So there'll be a heavy current will flow. Both the devices will get damaged. So this is a wrong, illegal connection. Please understand, this is an illegal connection. You should never connect like this in your digital electronics. If you connect 2 outputs, that is wrong. Wrong connection. But you know, how can you connect? You can connect the other way. You can connect the other way. That is, I put a tri-state switch. I have a enable 0, enable 1. When both the enables are 0, enable 0 is 0 and enable 1 is 0, both are 0, then the output is no voltage. Understand? Now this is 0, see 1, 0, 0, then this is 1. Now enable 0 is 1, this is 0, then this is connected. So this 0 volt goes here. This becomes 0 volt. Now enable 1 is 1. Then this is on. This is off because this is 0. Now this is 5 volt. This becomes 5 volt. But when both are 1, what happens? Both are 1, both are connected. This is illegal. You should never do that. And you cannot do that. That we will discuss when we are discussing about microprocessor. You cannot do that in your programming. You should never do both on. This is acceptable. So please understand, you should never connect 2 outputs together in your digital electronics without using a tri-state. But to differentiate the normal switch and the tri-state, In digital electronics, like OR gate, you have a symbol like this. AND gate, you have a symbol like this. NOT gate, we have a symbol like this. Like that. Tri-state, we have a symbol like this. No zero, no round here. That is inverter. Here there is no circle. So this is input, this is enable, this is I, and this is Y. So please understand, this is a very, very important one. That is, but generally you don't know. You don't know how, you don't know when your logic is there. You don't know that thing. You even see that. I may be using a both AND gate. And this is input A, input B, A, sorry, A, B. What happened now? If you connect, both are same type, both are AND gate. Okay. Now this is 1, 0. What happened? When you say 1, 0, this becomes 0 volt. But this become 1 and 1. This become 5 volt. This once again a short. Then what is the use? Both are going to be same. Then why should I use to do the same thing? There's no purpose of this at all. There's no purpose here at all. If you say A plus B, AB plus AB equal to AB, why should I waste one more gate? People never do this. Understand? So please understand, in digital circuits, never connect short two outputs. Never connect two outputs. One output can be connected to another input. That is correct. One output can be connected to two inputs. That is correct. For example, one person is talking. 5 people are listening. That is fine. Listening is no harm. But if 2 people start speaking, that is a confusion. That is wrong. Only one guy can talk at a time. So you understand this. So what we do here is we draw the tri-state like this. Enable. And we can have any number of input, 8 and 8. For example, this means if it is I, this is Y. That means that internally, I have 8 tri-state. And this is I0, I1 up to I7. I'm expanding because put 8. This is Y0, Y1 and Y7. But all of them having a same control signal. This is called enable. You understand now? That's how it's happening. So now let us do like this. For example, I have a signal comes here. Let's say this is called AD. This is called A. This is called D. Understand now? This is called AD. This is called A. This is called D. Now I have a signal called enable A, enable D, assuming. If you give here 10, it's a 8, all are 8, let's assume that. Now what I'm doing now, when I give 10 means 0, 0, 1, 0, 0, 0. This is LSB. This is MSB. This is Actually, now what happened? Let me tell you one very clear. This is AD8. That means that AD0, AD1 up to AD7. I given 10. That means 0, 0, 0, 0, 1, 0, 0, 0, 0. Now 0, 0, 0, 0, 1, 0, 0, 0. This is coming here. If you make enable A as 1, now this is connected. Now A become 0, 0, 0, 1, 0, 0, 0, 0. Understand? Now it goes to A. Now, if I change this one to 56, that is 0, 1, 0, 1, 6 means 0, 1, 1, 0. If I make enable D is a 1 and enable A is 0, this is off and this is on. Now this 55 goes here. The same way I'll explain to you one more here. See that. So please don't get here. Now what is advantage is this. I have a tri-state. I have a tri-state. I have a 8. See here, this is called enable A. And this signal is going to connect to this guy also. And this is enable B. This guy is also connected to this one. Enable. Now think of it. When you give here 20 and 30, if you give enable A is equal to 1, this is on, this is on, this goes to A. A goes to A. Now, if you give enable A is 0 and enable B is 1, now this is on, this is on, this is B. But this is called AB. This will act as a for some time, B for some time. That's why we call this as a AB. You know, we call this a multiplexed bus. That means that the bus will act as a or B sometime, depends on which switch is on. When both are 0, this guy is no voltage. So please understand. I'll give you one more application, how it is happening. Now you understand. Let us assume that I have a D latch. I have a D latch, 8-bit latch. You understand? Now I have a tri-state. Okay, now I connect this also. Understand, try to understand this picture. Sequential logic, tri-state logic. Now let us assume that this guy name is, I have a signal. We see that, how do we get the signal later? This is called 0 and 1. C0, C1. This is called enable 0, enable 1. Now tell me what is this? I'm using sequential logic. I'm using tri-state logic. I have a D, I have a Q. If I use C0, what happened? I have 4 signal. C0, C1, enable 0, enable 1. If we make C0 is 1, what happens? All the others are 0. What happens? Let's call this is D0, this is D1, and this is, sorry, that will give a confusion to you. Okay. Now what happened? If I give, no, I'm making C0 is 1. I'm using C0 is 1. This is no voltage. But whatever coming D will go to this Q. We may call this as a M0, M and N. The D goes to M. So the value, if we say 55 here, if you give D as a 55, the 55 goes here to M. But it cannot go out because enable 0 is 0. Since enable 0 is 0, it does not go out. This is trapped here. Now I change the data to 65. But I make C1 as a 1. Now D is 65. Now what happened? The 65 goes here to N. 65 goes here. But it cannot go out because enable 1 is 0. Now I make both of them 0. Since both are 0, this is 0, this is 0, the D will not get in. So this is what the 55 will be there, 65 there as such. Because C is 0. It retains. This is a sequential logic. Now, if you make enable 0 as a 1, that data will come out. Now this Q becomes how much? 55. If you make enable 1 as a 1, this is 0. Now what happened? This is 0, this is 1. Then the 65 will go out. Do you understand now? What I am doing now? What I am doing now? Do you understand now? If you understand that, I'm happy. You can unmute. You can unmute. There are 4 possibilities here. Anybody can unmute anytime and talk. There's nothing wrong.
Sir?
Yeah.
Sir, for 2 D flip-flops,
right.
Just for doubt confirmation, sir. For 2 D flip-flops, we can use only one tri-state. Can we use only one tri-state logic?
How do you use it? How do you use it? Tell me now. How do you use it? One tri-state logic.
Sir, for first D flip-flop, I'll keep one tri-state logic, and for second D flip-flop, I'll directly connect it to Q. So that if enable of that tri-state logic is 0, 1 only, then that output will come to
wait. I know that. If you are trying to do this way, am I right? You are trying to do this way. But
yes.
What happened? What happened? This is 65. 0, 1, 1, 1, 0, 1, 1, 0, 5 is 0, 1, 0, 1. This is connected directly to the wire. Now, when I make enable 1 as a 1, this is going, 55 is going to come here. That is 0, 1, 0, 1, 0, 1, 0, 1. Now what happened? There is a wire which has 5 volt and 0 volt. This is both the flip-flop devices will get damaged.
Sir, we are controlling both at a time, right?
Which you are controlling at a time. This output is digital, nah? This will be always coming. When the moment you give an enable, this will be short. Why do you want to do that without tri-state here? If you don't do that,
sir, we are not getting output at a time for both the D flip-flops, no, sir. We are getting
no, wait. Please understand. Doesn't mean that this case no. See, the output will be there always 65.
Okay.
See, please. I think you people are confused once again. Let me tell you one thing very important. Please understand the difference between deep sequential logic and tri-state logic. Please understand the logic. I have an input D and Q, and I have a C. When the input is C is equal to 1, Q becomes D. These are connected. But when C is equal to 0, Q is not no voltage. Q is Qn minus 1. So this will be either 0 volt or 5 volt. Whatever previously is there. For example, For example, if I did like this, D is equal to 1 and Q is equal to, sorry, C is equal to 1. Since C is 1, D is 1, the 1 will go here. Now Q becomes 1. Because D is 1, C is 1. But if we make C is equal to 0, now Q becomes 1. Whatever D, if a D becomes 0, that will not go out because C is 0. But the Q will be there as such. So the voltage in Q will be either 0 volt or 5 volt. So you are not supposed to connect. You are not supposed to connect. See, this is not possible. 2D flip-flop output. This is wrong because this is binary. This is binary. But this is possible. 2 tri-state output can be connected. Because you have a signal called enable 0 and enable 1. But both enable should not be 1 at a time, that's all. So this is possible. This is acceptable. This is right. This is wrong. That, see, when I don't give C means C, let's say C 0. This both are 0 means I am not giving the input. But that doesn't mean that the output is, this guy could be 0 volt, this guy 5 volt. This will damage both. So that's why I'm always telling you that you should never connect 2 combination logic like this. This is wrong. And 2 sequential logic. Because the sequential logic output is a binary, combination logic output is binary. But this is possible. Tri-state logic. You'll be very surprised. Only the 3 logics are going to be used in all our future product. Nothing more than that. Now I ask you one question. I want you to answer that. That is, I have a block of sequential logic. I have another sequential logic block. I have a tri-state block. I connect them. This is possible. This is correct legally because the tri-state. I have a enable 0 and enable 1. And now this output Q. Then this is D. This is input. I can short. One output can go to 2 inputs. That is acceptable. This is also right. Now I have a C0, C1. And this is enable. Now tell me, if I give D as a, this is D, this is Q. If I give D is equal to 55 and C is equal, C0 is equal to 1. All the others are C1, enable 0, enable 1. All of them are 0. C0 is 1. C1 is 0. Enable 0 is 0. Enable 1 is 1. Now tell me what happens. Now tell me what happens. Now I want anybody to let me know the answer. What happens now? This is a f of 1. This is f of 2. Flip-flop 1, flip-flop 2. That is assume. Sequential logic. Now what will happen? The D is 8 wires. These are all 8 wires. All of them are 8 wires. Now what is the output, please? No, there is one operation. There's one input is 1. So there is one operation taking place. If we say no voltage means where is no voltage? That's right. Now I'm asking that C0 is 1. Now what is happening? Now let me know here, you understand this or not? This is one of the major application of this tri-state logic, which you are going to see it on next class. I'm just giving a small idea now. So you'll be able to come in the next class with the preparation. It's Monday's class.
Sir, at Q, it is no voltage, sir.
Yeah, I'm not asking Q. Now I know the whole circuit, what will happen. I'm not asking about Q. Correct.
Sir,
Somebody has given a perfect answer. The output of f of 1 is 55. That's a perfect answer. There's one operation is taking place. Now what happened? This guy is off because C1 is 0. This guy is off because enable 1 is 0. This guy is off because enable 0 is 0. But this guy is on because C0 is 1. Since this guy is on, that 55, what I give it here will go here. Now it goes this. This, let us assume Q1, Q2. It goes to Q1. Am I right? Now Q1 becomes 55. Now I change the D. I change the D to 65. And I make C0 is 0 and C1 is 1. What happens? Now what happened? This is the first one. This is the second step. What happens now? I change this one to 65. And this is 0 now. And this is 1. And enable 0 is 0. Enable 1 is 1. 0. Sorry. Now what happens? Now, since C0 is 0, this is off. This is off. This is off. This is off. But this one is on. Yeah, this one is on. Since this one is on, Q2 become 65. But Q1 also become 55. That gets retains. Because C0 is 0, never forget. Now the Q1 55 is there as such. That is the advantage of the sequential logic. That guy remembers. That is called Qn minus 1. When I make C0 is 1, I transfer. When I make C1 as 0, C0 is 0. So now Q1 is 55, Q2 is 65. Now both are there in the YS. But it cannot come out. It cannot come out. Now what I do here, the third one, D could be anything because I'm not giving C0 is 0, C1 is 0. But I make now enable 0 as 1 and enable 1 as a 0. Since enable 1 is 1 now, and this is 0, and this is, let's put a tick mark here. That is book. This is wrong, off, because this is 0. But this one is on. Because enable 1 is 1. Sorry, enable 0 is 1. Sorry, this is off. I did a mistake. Sorry. Enable 0 is 1. Enable 1 is 0. So this one is on. So the 55 will come out. Q become 55. So I'm reading the first data. I'm reading the first data. Correct. I'm reading the data of what is written on Q1. Now, if I make fourth possibility, dx, but C0 is 0, C1 is 0. I don't do anything inputs. Now, I make enable 0 is 0 and enable 1 is equal to 1. Since enable 1 is 1, this is connected. And this is not connected because this is 0. This is off now. This is connected. Now this becomes 65. Correct. Now you see here, I do 4 operations. Understand, I do 4 operations. First one is write on flip-flop 1. Write on flip-flop 2. Read from flip-flop 1. Read from flip-flop 2. Am I right? I do 4 possibilities. Am I right? I do write, I do read, and I also do store. The problem is when all of them are 0, let us assume that now all of them are 0. C0 is 0, C1 is 0, enable 0 is 0, enable 1 is 0. When all of them are 0, so this is not connected. So no output, and no input because all of them are 0. But still, this guy remembers 55 and 65. So this guy will act as a memory. You know what is this called? This is called read, write, memory. There are 3 operations. I am writing, I am reading, I am making it to remember. This is actually called, supposed to be called like this. Read, write, and memory. Read, write, memory. If you shorten it, it should be called RWM. But unfortunately, engineers have called by mistake, this is a RAM. Engineers have called this as a RAM. Understand now? This is a mistake did by the engineers. Okay. I'll tell you the mistake when I'm discussing about RAM next class. I will explain to you that why they have called this as a RAM, even though it is a RWM. So now we are slowly moving. Now in this RAM, I'm storing 2 numbers. I'm storing 2 numbers. I can store anywhere, I can read anywhere. But how could it possible? That is what we are going to discuss on next session. I've given a small idea that how sequential logic is used in the RAM, how the tri-state logic is used in the RAM. And we are going to discuss on Monday, next session on the RAM. Not Monday, sorry, Tuesday. We're going to discuss about how the RAM works. That will give you the perfect idea of the RAM. Is it clear? If you have any doubt here, ask me. Please understand. Please, I have a small request. Before go to next session, watch the number system videos thoroughly. I have uploaded the number system videos in our. It's very simple, but still it's a binary number system. You have to understand what is 2 power 20, 2 power 16, everything. In our folder is the number system videos. We cannot connect the outputs, but I can connect the output to input. Any output can, in digital logic, any output can be connected to input, but I cannot connect 2 outputs. That's the problem. I cannot connect 2 outputs. Is it clear now? So this is what I have given a small idea of this, but please understand, before we come to the next class, we have some good time. Before we come to the next class, okay, that is on, I think, Friday. Please make sure you have another 3 days. Make sure that you understand CL, SL, and TL. these three. CL is nothing but simple. I have some input, I have a name, I have output. And the SL is I have a D, Q, and C. TL is I have I, Y, and enable. That's it. And plus, another request is watch the number systems videos. And if I ask you that, what is 2 power 26? How much? Can you give me an answer in 1 second? If you can give an answer in 1 second, you know number systems. What is 2 power 26? Think of yourself. Can you give an answer in 1 or 2 seconds? If I ask you 2 power 34, how much this is? 2 power 27, how much? 2 power 44, 46, how much? You should be able to give the answers to them in exactly 1 or 2 seconds. Such a perfection I need. Such a speed I need. So practice that. I can write, see that. 2 power 43, 8 tera. 2 power 34, 16 giga. 2 power 27, 128 kilo. See that, I can write. When I'm writing itself, I can write that fast. So please understand that. Also, both are same. Both are same. Unfortunately, RS latch and RS flip-flop, they are different. They are not same. But D flip-flop and latch, both are same. Please, there's a big confusion now. Don't get confused between these two. Flip-flop and latch are same, please. No change, no difference at all. Okay, then let me stop the recording.